All right, on to our last type of examples, which are real life applications. These are ones that are actually going to make sense in the real world. So we've got this graph, and it shows us the toll, which they're representing with the variable y, due on a turnpike for driving X miles. Your toll is $7.50. So how many kilometers did you drive? We've got a lot that's being thrown at us here. So I see that we've got toll is going to be our y value. So on a coordinate, we're always going to have an x comma y. So that means our total is always going to be the second number right here. And then it says for driving x miles, so miles will be this first one, the x, on those two coordinates. So it says your total 750. How many kilometers did you drive? So we've got a couple things to think about. The first thing I want you to think about is which is further. Is a mile or a kilometer longer? And you might not know the answer to that. So what I've done, and you're going to need this for pretty much all of these examples here at the end, is this conversions chart. So we need to go on there and we need to look and find where do we have the mile to kilometer conversion. And it's okay if it takes you a minute to find it, but I've already found it and it's right here. So we're going to be using this 1 mile equals 1.609 kilometers, which means that a mile is actually longer than a kilometer. But we're going to need that conversion in order to solve this problem. And then the other thing we're going to have to think about is what do these points 100 comma 7.5 and 200 comma 15 mean? And hopefully as I was reading the question and explaining the whole coordinate thing, you started to get an understanding that what this means is that for like if you drive 100 miles, then the toll you're going to have to pay is $7.50. And then also for the second one, if you drive 200 miles, then you're going to have to pay a toll of $15. So the question is telling us that our toll is 700, I lied. It's $7.50. So they want to know how many kilometers did we drive? Well, if we had to pay $7.50, that means that we drove 100 miles. So we're going to be working with 100 miles. And now we're finally going to get to see why that dinosaur, why he meant business, why we do need to label. So I'm going to go ahead and write that we have 100 miles and we need to figure out how many kilometers that is. So we're going to write this as a proportion. So because we want to know how many kilometers we drove, we're going to take our 100 miles and I'm going to put that over our variable, which we'll call it x because we don't know how many kilometers, and I'm just going to call that km. And the way that we can solve this is by setting it equal to that conversion that I showed you just a moment before, which said that one mile was equal to, let me look at it again, 1.609 kilometers. 1.609 kilometers. So now we have two ratios that are set equal to each other. So this is a proportion, and because they're set equal to each other, we can solve for this variable right here, which is x. And the way that we can do that is by doing cross multiplication. So we can multiply 100 times 1.609. And I'm going to do that mentally just by sliding my decimal. If I'm doing 100, I'm just going to slide this over 2. So that gives me 160.9. And then the other cross that we're going to perform multiplication is the x times 1, which is just 1x, or I'm just going to call it x. So remember we wanted to know x was how many kilometers. So 100 miles equals 160 kilometers.